Hello everyone. How was biology exam today? I hope it was lovely. So let's quickly look at what I want to do today. I want to quickly talk on NECO chemistry practical because of the practical exam that is coming up on Monday. I know that practical section we have theory section. We have the section for the quantitative analysis or titration. We have the section for qualitative analysis, and then we have general knowledge. That's the third section. So this first section that I want to talk about is extremely important. This quantitative analysis section. Your exam that you're going to be doing on Monday is 50 marks. That's the practical. And out of the 50 marks, sometimes around 21 to 25 marks out of it will be from this question. That is section A. That's some quantitative analysis. So please be serious with it. So let's look at the question. A is a solution containing 3.15 gram of HNO3 per 500 cm cube of solution. B is a solution containing 8 gram per dm³ of a mixture of sodium triisocarbonate 4 and sodium triisonitrate 5. So the way I'm looking at this question, what they will ask, the way I'm looking at it, because of the mixture that is present in solution B, sometimes they might ask on percentage purity. But just look at the question that I just said. This is a model question. I'm not actually saying that this is what will come out on Monday. So put all the burettes and that, repeat the titration to obtain a consistent titer, tabulate your results and calculate the average volume of acid used. So they've given us the equation of the reaction too. Now let's look at this table. Let's look at the table from the volume of pipette used and then the indicator used. And something that NECO usually do most time is that NECO will draw the table for you. NECO will draw the table for you, but you are going to be filling the value by yourself. So there are something that you must note. That you must remember to write the volume of your pipettes used. It is 20 or 25. But most schools that I know are using 25 cm³. And the indicator used either methyl orange or phenolphthalein. So what I'm using phenolphthalein here. And when you are observing your reading too, your value must be in 2 decimal place throughout. Even when you want to write 0, you don't just write 0. You have to write 0.00. Please, you must have a consistent decimal place. That is 2 decimal place throughout in your readings. So look at my readings here. And I usually say again, I'm not saying that this is the standard titer value for whole school. I repeat again. Use the value of your own school. Ask your chemistry teacher and use the value of your own school. But I'm sure that the value of your school will be around this range. But don't let me just assume. But this is my titer value, the first titration, the second titration, and the third titration. And as you can see, they are concordant. The meaning of concordant titer value is that the difference between the highest value and the lowest value is between the range of 0.2 cm³. Difference between the highest value and the lowest value is between the range of plus or minus 0.2 cm³. And you can see that these are in a range. In fact, first titration and second titration are the same. And the third titration is 26.10. So if you minus it from the previous one, it's just 0.10 cm³. So it is within that range. So they are concordant, and I take the average. So that is how you calculate your titer value, or the average volume of A use, or the average volume of acid use, depending on how they bring it on Monday. So now let's look at the question that we want to solve. That's the concentration of solution A in mole per dm³. So let's look at this model question. If you look at solution A, It states here that it contains 3.15 gram of HNO3 by 500 cm cube of solution. So now look at that Roman figure 1, the solution. We should know something, that this formula, that concentration in mole per dm cube is equal to mass concentration over molar mass. Concentration in mole per dm cube is also called the molar concentration or molarity. And then mass concentration is also the concentration in gram per dm cube. So now look at how I got my mass concentration. That is mass of solute over volume of solvent. The solvent that we're giving here, they said that per 500 cm cube of solution. So that 500 cm cube, I converted it to dm cube. And how do you convert 500 cm cube to dm cube? You divide by 1000. So that is why I have 0.5 dm cube. Then I just divide 3.15, that's the mass, over the volume. And I got the mass concentration as 6.30 gram per dm cube. I did the molar mass of HNO32, which is 63 gram per mole. And please, when you are working on Monday, you must always put your units. You must always put your units must be clearly stated, please. And then concentration in mole per dm cube, that will just be the mass concentration over molar mass, which is 6.3 divided by 63, which is 0.100 mole per dm cube. Sometimes people might ask that, why am I using 0.1? Why did I not just write 0.1? Why did I just write 0.100? Because when you are working with concentration, in fact, I will even advise you, any calculation that you are doing on Monday, let your answer be in 3 significant figure. It must be in at least 3 significant figure. That is why it is 0.100 mole per dm cube, not 0.1. The answer must be in 3 significant figure. Now let's look at Roman figure 2 question. Concentration of sodium triisocarbonate 4 in B in mole per dm cube. We should know something from the nature of the question here. That B contains a mixture of sodium triisocarbonate 4 and sodium triisonitrate 5. It is that Na2CO3 that is actually undergoing the reaction with HNO3. HNO3 cannot react with NeNO3. It cannot react. It is actually that sodium triisocarbonate 4 that is undergoing that reaction. So I hope you get that one. It's that sodium triisocarbonate 4 that is undergoing that reaction. So let's look at that Roman figure 2 clearly stated there. We use the formula CAVA over CB, VB is equal to NA over MB. And when we make CB the sort of formula, we get the answer that we are looking for. And you can see that it's also in 3 significant figure. So please, your answer must be in at least 3 significant figure. So that is CB. And the C is what we got in Roman figure 1. The VA is your titer value. That's 26.17 for me. It might differ from you. Then MB, if you look at the equation of the reaction, in front of Na2CO3, there is 1 there. My thing that is invisible, there is 1 there. That is why my MB is 1. And in front of HNO3, we have 2 there. That is why that is why our Na rather is 2. So we've gotten that one. Then the third question, let us to find the concentration of sodium triisocarbonate 4 in gram per dm cube. So concentration in gram per dm cube is concentration in mole per dm cube times molar mass. So we just find the molar mass of Na2CO3, which is 106 gram per mole. Then the concentration in mole per, we've gotten that one in Roman figure 2 before. So when we slot it to each other, we'll see that it is 5.54 gram per dm cube. That's the mass concentration of Na2CO3. That's the mass concentration of Na2CO3. And let's look at the fourth question. The mass of NeNO3 in B. And this one, you have to first understand the concept here. B is a mixture containing 2 salts. Sodium triisocarbonate 4 and NeNO3. So the mass of Na2CO3 in 1 dm cube is 5.54. and the mass of the mixture, in 1 dm cube, total mixture 1 dm cube is 8 gram. So the mass of our NeNO3 will just be the mass of the total mixture minus the mass of sodium triisocarbonate 4, which we have done here. It is 2.46 gram per dm cube. Like, still 2.46 gram. I'm sorry, it is 2.4, not 2.46, not 2.4. So we just made that little adjustment in that. Now then, the Roman figure 5, they ask us to find the percentage of NeNO3 in the mixture. So this is the formula that we are going to use. That's the mass of NeNO3 over mass of the mixture, the total mass, times 100%. And when we slot in our value, we will get 30.75%. So that's that. You can just check it again. And I will put this PDF file, I will put it in the comment section too. Just check it again and practice more. I'm not saying that this is what will come out, but just find more questions relating to percentage impurity, percentage purity, and the rest like that. Just find more questions and practice more. So I wish you a very wonderful exam. God be with you. God bless you. And please don't forget to like and subscribe. Have a wonderful day.